In this video, I'll be talking about complex algebra and imaginary numbers. And this applies to circuits because a lot of resistances or impedances, once we start dealing with capacitors and other forms of resistance, actually end up dealing with imaginary numbers, which are shown as J. And we still need to be able to manipulate all these resistances or impedances to be able to show how the whole circuit will flow. So this is just kind of the math that is going to go on behind these, and I'm going to do a separate video on how we find all of these impedances and how we actually apply them. But for the math, the easiest way to think about it is there's two forms. There is either rectangular or polar. So polar is what we would usually think of for our, rectangular is what we would usually think of. We have an X and a Y, and our polar then is when you would have a distance or an angle. They're both going to be showing the same point on your graph, but they're just represented in different ways. So for example, if I have 5 plus 6j, I'm going to have 5 as a scale for my real numbers, and on my imaginary, I'm going to be all the way up at 6. Okay? I could also find that number in polar just by doing some simple trig and do Pythagorean theorem to find my distance, and then I can do the tangent inverse of the opposite over the adjacent to find the angle. So that was Pythagorean theorem or tangent inverse of the opposite over adjacent. Okay, and that is to go from rectangular to polar. So the other way that I'm going to have to know how to manipulate these and change these between is I'm going to have to go from polar to rectangular. And that, in the same way, is just going to be using some trig. If I was given this distance and this angle, I can do the distance times cosine or sine of one of these distances. So I can do a cosine of or a sine of, depending on which one I'm looking for. In this case, cosine should always help you find, I believe it is this, the real numbers, and sine should always help you find the opposite or the imaginary. Now, that's to switch between, and as you can see, that's just represented in our graph. So, looking at the two numbers I gave you guys here, we have 5 plus 6j, we've shown that one. The other one that we have is 2 minus j4. So once again, that's going to be 2 in the real plane, but I'm going to go down in the imaginary. Just be careful to note of if you're negative or positive, and because this goes in this direction, but I always reference the x-axis, then I'm going to be looking at this angle. So in this case, I might actually have a negative angle if I'm going to be looking at it from here. So in this case, I did the math already, but if you guys want to, you can follow along with these numbers. So addition and subtraction, you simply add them, just keeping like terms like you would with any other variable. 5 plus 2 is going to be 7, and 6 minus 4 is going to be 2j. Addition and subtraction, the easiest form that you always want to do is in rectangular. You always want to do rectangular for addition and subtraction. That is the opposite for multiplication and division, because j's are annoying and are hard to multiply or divide. So when you're doing multiplication or division, you always want to be in polar. Okay, so if you're doing multiplication or division and you're given the rectangular, we want to do what we just talked about to be able to switch it to each one to be polar for us to be able to do multiplication or division on them. If we're given polar, then we can just stay in that form, obviously. So 5 plus j6, I believe, is 7.81 at an angle of 50.2. And I'm going to multiply that by 4.47 at an angle of negative 26.6. So for multiplication and division, they're really similar. I'm going to multiply the first numbers or divide the first numbers. And then for the angle, I'm going to add the final angles or subtract the final angles from the top one. So for multiplication, in this instance, we get 34.9 at an angle of 23.6. We got that from 7.81 times 4.47. And then we took 50.2 plus negative 26.6. That would be our final answer for multiplication. That would be in polar form, or we could switch it back to rectangular if needed. But once again, the big idea out of this is that multiplication and division are way easier to do in polar, so we always want to switch it to that. Whereas addition and subtraction are way easier to do in rectangular. Try to keep it in rectangular. Then for division, as I just said, we have our 7.81 at an angle of 50.2, and we're going to divide that by 4.47 at an angle of negative 26.6. And I believe we get 1.74 at an angle of 76.8. And we got that from 7.81 divided by 4.47. We divide the first number and subtract the final numbers. We took 50.2 minus a negative 26.6, actually it was a bigger angle, so it would put us at 76.8. And if we wanted to think about what those would look like on our graph, we would have an angle of 23.6, would be something like this maybe, and this distance would be 34.9, and our angle would be what was given at 23.6. Then we could also do that for this, but 1.74, much shorter at 76.8. Both of those can be shown on there. Once again, big idea, addition is in rectangular, multiplication and division is in polar. To switch between rectangular or polar, you just think about what it looks like on the graph, try to do some trig to it, either doing tangent inverse or cosine or sine, and that's about it.